Brenna turned it on, Carol. You turned it on.
Oops.
I did break up the green thing over there. Oh, did you draw a picture?
Yeah.
You know the funny thing? When I taught this 2 years ago, this, like, I think we did the problem in class, and then, like, later that night when I was at home, I, like, had a ladder up against the wall in my garage, and I climbed it up it, and it started sliding, and I fell. I was like, whoa. It's like, that was awesome. I didn't get hurt. And I was like, that was awesome, because we just did that problem.
That's
I
funny.
can really see it. It was
Your
wild.
life is so full of irony, it's funny.
Huh? It didn't slide fast. It just went like, I was like halfway up it. I was right there and it started sliding and it just went, and I stood up and I hit the ground because the ladder went bam, hit flat.
Yeah, that's how my dad kind of broke himself. Ladders are.
Yeah. Okay, so we got a ladder. It's 13 feet. That's not going to change. That's key.
Ladder's never getting shorter.
I just did this as X and this is Y because usually that's the X direction and that's the Y direction.
I heard 9 kids. My mom had 8 kids.
Hey, your cat.
The bottom is drawn away at 3 feet per second. What does that tell you?
That the rate of X is 3
So dx
Feet per
dt
second.
is
That's what I meant.
3 feet per second.
3. Everyone draw their picture this
Feet,
way.
right feet per second.
I didn't, but I just redrew
Because
it.
if you draw it this way,
Yeah, I drew that one.
you could make an argument that dx dt is negative 3 feet per second because the
Oh, I
ladder is
kinda
going that way.
changed it right
Can
now.
you put feet per
And
second?
if you draw your picture this way, you need to continue to do your problem this way. It does not matter which way you draw it, and it doesn't matter if you have 3, there you go,
Thank you.
or if you have drawn this way, you need to do negative 3, but you need to be consistent with yourself. Did you do it this way, Brenda?
I did that way, but now I'm getting confused, so I'm just gonna do your own.
It'll end up being the same thing.
No.
So then what else we got here? How fast is the top of the ladder sliding down the wall? So what's that tell us we're trying to find?
Why?
Yes.
dy
dt. Trying to find the rate at which the ladder is sliding down the wall.
Why can't I do this by myself? I can see it right now.
So trying to find dy dt.
So you also have to realize what you're solving for.
Yeah. You have to realize what it is they're giving you, what parts of it is actually
It's not always just an answer.
and realize what you're looking for. How fast is sliding down the wall? When the bottom of the ladder is 5 feet from the wall. So what does that tell me?
That
When
X is 5.
Yeah. It's asking how fast are you going when this is 5, when x is 5. So, usually you have to write an equation that's going to relate to the things you got going on here. You know of one?
X squared plus Y
Yeah.
squared
Isn't it just a
equals
right triangle?
Back and down.
250.
Good old Pythagorean theorem, x squared plus y squared. 13 squared is 169.
Oh, that's the answer.
And then you plug in 5 for x.
So now, hold on. In order, since we want to find dy dt, couldn't we do the derivative of this?
Yes.
Plug in dx dt and x. What? Notice that's how they all go. You write an equation, you do the derivative of it, you plug in the stuff that you know, and figure out what you don't know, right? How did I get 169?
13 times 13.
13 squared. Pythagorean theorem. A squared plus b squared equals c squared. Derivative of this then.
2x dx
2x
plus
dx
2y dy
dt
That's what I did.
2y
equals
dy
0.
dt equals 0. And then
So why does it equal? Oh, 0, because the derivative of 169 is nothing.
0,
Yeah,
yeah.
okay, I get you. Just kidding.
She does.
So, hold on then. If I plug in x, I plug in dx dt. Ooh, don't I still have a y and a dy dt?
But you can use Pythagorean theorem
But
without.
can't we figure out what y is?
Yes.
Because when x is 5 feet away, then won't it look like this? This will be 5, this will be 13, and I'll figure out
So you
what
just
y
do
is.
regular Pythagorean theorem.
Yeah, so then just do Pythagorean theorem to figure out what y is at that moment. So at the moment they're looking for, do Pythagorean theorem, you'll get y equals 12. It's 5, 12, 13. You should have that one memorized. It's like 3,
There's only 3, right?
3, 4, 5, 5. No, there's tons.
Well, the 3 that you taught us in geometry.
3 I said to memorize were 3, 4, 5, 5, 12, 13. It's just
So is pencil squeaky?
Yeah.
Mine.
No, there was another.
Was there another one?
Is there one with 4?
I'm trying to write, I'm sorry.
No.
Unless it's, you're thinking of special right track rules.
Oh, maybe that's what
Like
it
if
was.
it's isosceles, it's a 45, 45, 90.
Oh, yeah, yeah, yeah. I think
1, 1, square root of 2.
that was the other one.
Trust me, you'll get y equals 12. Plug it in. Solve for dy dt. You can handle that. Alright? So you get 2 times 5.
-5 word scale. Yes.
Good, no one said 54 dy dt equals 0. You probably would have. And I'm like, it just equals 0. Like, no. Subtract 30, divide by 24. -5 fourths, what are the units?
Feet per second.
Did we get asked for how fast something's moving? So it's just going to be distance divided by time.
Number 7.
Number 7.
Yeah.
It's the same
NA.
problem. You just do it. They're just asking for a different thing. How fast is the angle of elevation of the ladder changing at the instant when the bottom of the ladder is 5 feet from the wall?
I am?
Yeah, that's the end.
Are you sure?
So we still have a 13-footer.
Number 5, no?
And still want x equal to 5. What are we trying to find though?
We're trying to find theta.
How fast is the angle?
Theta, good word. Yeah. Where are you going to put that theta?
Bottom.
Up here, down here?
No, at the bottom.
Down at the bottom, yeah, because it asks for the angle of elevation. That's the angle that's going up. So we're trying to find theta. We know x is going to be 5 feet. Is that all we know?
So how would you write that? Find D theta over dt.
I think we still need...
12.
The change.
Oh, you'll see. Let's just go from here. That's still y,
Which is still 12.
which
No.
is still
Yeah.
12 at that instant. But don't just put a 12, because y changes. It's a variable. At the instant this happens, it's 12. But when you're...
Wouldn't x be constant?
No.
Because it says when it's at 5.
It said, okay, these change because the ladder's sliding, but it's asking for the rate that that's changing when those are that. But you can't just say x is 5, y is 12, find theta. That's just going to give you the angle it is at that instant. It's not going to give you how fast it's changing.
So you have the tangent theta of y over x.
Do you want to do tangent of theta equals y over x? Guess we could. We already know.
No, we already know 13, so let's use it.
So
Yeah, I like to use the solid number if I got one.
do
Do sine? Okay. I know, that's what I did on the paper. But we could do it differently than on that paper.
No.
Opposite over.
Cosine, we could do cosine. If we had just assumed that this is still true,
opposite.
which I think we need to on this one.
Yeah, can we use
No,
cosine
assuming-
using x?
Sure, let's use cosine. Let's do it different. That way you'll have it 3 different ways. You can
Oh
look
my
at this,
God.
or you can look at that. So you can do cosine of theta, see if we get the same thing. It's a good challenge. cosine of theta equals
X over 13.
x over 13.
Which means theta is equal to the inverse sine of cos.
So yeah,
Inverse cosine.
at that instant, theta would be equal to the inverse cosine of 5/13, which might be good to know. I don't know.
The inverse of cosine is
Negative 1 over square root of x minus 1.
nope, 1 minus x
No, no,
squared.
no.
What?
I'm not doing that.
No derivative.
Never mind. I'll just do it your way you guys are doing. You want to do the derivative of that?
That's what we're
There's
supposed
two
to
options. I put them on here.
Do the
You
basic.
can either do the derivative of that and then solve for d theta dt, or you could solve for theta first and then do the derivative of the inverse cosine. To me, the derivative of cosine is a lot easier than the derivative of inverse cosine.
So you just
Don't
solve
you?
it that way with the
Yeah.
derivative?
Do the derivative of that.
So you would have the negative
What's the
sine of
derivative of
theta.
cosine?
Negative sine.
Negative sine of theta d theta dt. Right? When you do the derivative.
Equals.
Equals.
here?
Push. No. Just kidding. I don't have to
Just
do
do
that.
1/13 x.
Which would be.
What's the derivative of 1/13 x?
113.
1/13.
That makes
Yeah.
sense.
And anything we're forgetting?
D
Yeah.
dx.
I changed this.
To
We need to
1/13
go
x.
just do derivatives. because this-
Well, we used to do derivatives and never have to put the d things.
Oh, yeah, that's the only thing to do. This, isn't that the same as just 1/13 times x? Yeah, and if you do the derivative of something times x, isn't that just something? Yeah. dx dt. Now what?
You plug in. You don't have your dx dt or d theta.
Yeah, we're assuming it's the same from the other problem.
Oh.
I know. I don't know. Like the other day.
What are you gonna do?
You're gonna
Like what you
divide
know.
by negative sine.
Yeah, do you know theta?
No.
That's what I was doing over here. I was trying to find theta. See? At that instant, what is theta so that I can plug it in
So
here?
you could put inverse cosine of 5 over 13.
Yeah.
For data.
The other thing would have been easier to
So you
do.
do negative
The other derivative.
sine of the cosine of inverse. What?
So you have the cosine, inverse cosine of 5/13 is equal to,
No, don't you have to do times?
yeah, he said plug in theta.
Yeah, but you still have negative sign.
Yeah, well, you're dividing by that.
Yeah, don't look.
I'm so confused.
All I know is dx dt is 3 at that instant.
That's true. Didn't I just do the derivative of that? Aren't I trying to solve for this?
Yeah.
So don't I need to plug something in here and here?
Yeah,
So do I know this?
Yeah.
Yeah, from the first problem. Do I know this?
No.
No, so I'm going to find it. How do I find theta at this instant?
The
Ooh,
inverse
don't I know
cosine-
5, 12, 13? Don't I know that's what it is at the instant we're looking at?
yeah.
So can't I do any of the, pick one, sine, cosine, or tangent?
And
Tangent of theta equals opposite over adjacent. Isn't that 12 over 5?
Yeah.
And then you
The inverse,
use your geometry and just do inverse tangent of 12/5,
which is the same as the inverse cosine of 5/13.
which is the same as the inverse cosine of 5/13, which is the same as the inverse sine of 12/13. And you do it in your calculator and you get the angle, then you plug it into the other one.
I don't have a calculator right now. Don't know where.
I could never plug these into
I'm
my
pretty sure I
calculator.
left my calculator in here on my desk and it never showed up again.
Remember what
So now
number it was?
I'm gonna hit the 8, I think. 22 maybe?
I have them written down somewhere.
Are you supposed to like round it or what?
You have to.
So 1.18 is that what we got? For the-
1.18. What is that? 1.18? What? What's 1.18?
Is that?
So do you divide by negative sign? I'm confused.
Of 1.18.
Oh, so you, okay, so you solve for theta, put in theta, and then
Wait.
you divide by the
What
sign
is
of that number?
Where are you confused?
I don't even want to plug it into the calculator.
Hit second tangent,
It gave me second tangent.
parentheses.
No, it gives me one. 12.
Okay, 12 divided by 5.
And it gave
Enter.
gave me 67. That's why I said one of my.
Because you're in
Think about it.
degrees.
Yeah. In degrees.
Yeah, Wander's telling people, what?
Good job. I don't even know how to change that.
You have to hit mode.
I'm really glad we already decided not to try the AP test. That would be freaking out right now.
What?
Not just you.
Good.
Okay. Refocus. Got theta?
Yeah.
There is a better way to do this,
So
by
now,
the way.
now we plug it in
Yeah.
where it's supposed to go.
Plug that in there.
And then we divide
And
it
I'm going to
by.
show you a much faster trick here in 1 second. But I just want you to have one method. Times d theta dt. 1/13. Do we know this?
Yes, 3.
3. Okay, so can't we just divide by this?
Yes, of 3/13.
Take 3/13 and divide
It's
it by the
negative.
negative sign of 1.18.
It's negative 0.25.
Holy shnikes, no way.
Yeah.
You know what the units would be?
Radians?
Per second.
You don't even finish. Jeez.
Rad, dude. Want me to show you a little shortcut?
Yeah.
Right here.
Negative 1/4.
Watch this.
Point.
This is going to blow your mind.
Negative 0.25.
We had this, right? And we just needed to plug in dx dt, which we knew was 3. If we wanted sine of theta, remember when I told you to pick one?
Yeah.
Why don't you just pick sine? And then that would be opposite over hypotenuse, which would be 12/13, right? Well, that's negative, so you would just put negative 12/13 equals, or d theta dt equals 3/13. And if you divide by 12/13 on both sides, you'll get -1.
So choose the sign that's on there.
Yeah, well, it's just this whole thing is easy to see. It's right here. It's 12/13. It's just a different way of plugging it in, because you could know what the sine of theta is, and you don't have to solve for theta and then plug it back in. You just know the sine of theta. You want to try it the inverse way?
No.
You can
Just
do the
go
same
to-
thing.
Go to the next problem.
We can do it with inverse sine, or we can do inverse cosine.
There's another one that does tangent and stuff like that, so continue. Number 9.
That's the one inverse.
Or we can just do number 8 and then we'll be done.
8 and 9 fast. Let's see what they have. Baseball diamond is a square whose sides are 90 feet long. Did you draw a square?
Yeah.
I drew a
So I just
diamond.
threw my
Yeah,
paper on.
diamond.
Yeah, me
At
too.
first I drew home plate because I was confused
Yeah,
with the
yeah,
balls.
me too. Well, I don't know about baseball, but I was just drawing.
That's a square. Doesn't look like it, but it is. Where would it go?
I even labeled my home plate.
90 feet. Cool, yeah. Did you draw? I hope you drew it correctly at least.
I said I labeled it, I didn't say drew it.
Oh, okay.
I tried. Hey, it looks like
I
that.
hate
Though.
when like you see like a picture of a baseball field somewhere. Like I'll see this, and then they have home plate drawn on there like this.
Like a house.
Oh, it bugs me. I'm like, what is?
Well, actually, I just drew right
It's
commence.
home.
The
It's a
point of it
house.
points towards the catcher, right?
No.
Yeah. Yeah, Brenna.
Okay, thank you.
We're just drawing houses.
Homes.
Homes. Suppose that a player running from second base to third base.
Yeah.
Did you draw the little guy running?
No.
No?
Oh, there he is. He's running.
That's That's not a die, that's a circle.
If I'm a bird, it looks like a circle.
You're a bird, I'm a bird.
We are human. Just kidding.
I actually understand that. My wife says
They said if you're a bird, I'm a bird.
Yeah,
It's
that's
not
what-
a movie.
that. He's going 30 feet per second. Ooh, how long is it going to take him to get to third base? Depends on how long Biggie let off. All right. At the instant when he is 20 feet from third base. Okay. My picture's too small. Here's this guy. He's going 30 feet per second. Here's the baseline.
We can't see.
Here's third base
Sorry.
before he goes home. It says at the instant when he is 20 feet from third base.
Does it even take up 3 seconds?
30 feet per second.
20 feet from third base. At what rate is the player's distance from home plate changing?
Oh, I didn't get that until now.
So, this is weird. You've never seen anything like this before in your life.
Stupid.
There's no way you could have done this by yourself. Sorry about that. This should be like...
I'm like, do I have to do like 2x because he
So,
runs?
the problem is asking for how, like the guy's running, and it says when he's right here, how is his distance from home plate changing? It's not asking how his distance from third base. He's
It
going
is decreasing.
30 feet
And-
per... He's getting closer to home plate, isn't he?
Yep.
But at a weird angle. So I want to know how fast is he getting closer. If he rounded third and started coming home and it said how fast is he approaching home plate, you'd say, oh, 30 feet per second because he's running directly at it. But here he's not running at it, is he? He's going this way 30 feet per second. He is getting closer to home plate, but not at a rate of 30 feet per second, right?
So basically drawing a triangle.
So basically, yeah, we're going to draw a triangle.
Dang.
Because this is what
I'm
we're
sick
gonna
of
try.
triangles already.
Trying to find some equation.
I know.
Told you this
Like,
gets
that's what's
hard.
funny, like 2x.
This is day 1 problems. Wait till we hit day 2, day 3 problems. They get harder.
There's harder than
Ours
this?
is more like
Yeah.
day 4.5, day 7.5.
We'll be doing these for like the rest of the week, so, and not take a quiz yet, and then come back and then still do them for a few days.
And how fast did the last two that you taught? Did they go to
It takes 6, 7 days probably of this before it's like, oh, okay, I can finally do it.
If he gives us math or homework over spring break, I will cry myself to sleep.
You have a big project and videos to watch.
Oh,
Don't even. We don't have any rush.
Yeah.
We don't gotta do homework over the weekends anymore. We don't have to.
Okay, whatever.
We're just chilling.
Moving on.
Let's label the sides of our triangle.
You have a 2090,
Well, but we want to use variables because the guy's
so
running.
X, Y, Z.
The guy's running. The only one that's not going to change is this one, right?
Yeah, which is
But
90.
let's just label it X, Y, Z, is that what you want to do?
Yeah.
sure.
Which one's which?
X is 20, Y is
Okay,
90,
X
and Z
here.
is
Just saying.
Y here, Z here?
yes.
Sure.
Point is, it doesn't matter. Is there a relationship that we know between those three?
Yeah, they all change at 30 feet per second.
Nope.
Oh, just X does.
Just X changes it. Oh, so what would that be? What is 30?
dx dt.
dx dt
I already have that written down.
is 30.
When X is 20.
You want to call it positive or negative 30?
Positive.
Positive.
Okay.
When X is 20
When X is 20.
feet.
What are we trying to find?
The distance from, actually
He
Z,
is from home
basically.
right now. At that.
I want you to tell me, answer my question with either x, y, z, dx, dt, dy, dt,
Z.
or dz, dt.
dz dt.
No, you want to find, did you
Am
say
I?
DZ? Yeah, that's what I was going to say. DZ.
Read what it says.
Hard to say.
dz dt.
At what rate is the player's distance from home plate changing? This is his actual distance from home plate, isn't it?
Yeah.
So the rate at which that's changing,
What am I doing?
you're trying to find
DZ,
dz, dt.
So the only thing we do not know is Z and dy dt.
We don't know z, we don't know,
We don't know why. Why do we need
Yeah, we do
y?
90.
Why
is y changing in this?
No.
Before he, because he hasn't come around third base yet.
No.
It's
So-
not going to change.
It's not going to change.
So, y is 90. Well, you don't know dy. Oh, you don't need that. Yeah, you do.
Let's write an equation. What equation are we gonna do?
Pythagorean
Because
theorem?
we're gonna write an equation to the derivative.
Yeah, it is.
It's a right triangle.
Oh, yeah, it is.
Remember it was a square? Yeah, it is a right
Okay,
triangle.
Joshua, come on.
So we can do
He
x
said, "Gosh,
squared
Janai,
plus
come
y
on."
squared equals z squared.
I'm dead.
But can't we keep the number of y constant since it stays the same? That way we only have two
Yes,
variables.
because that's just 90, ain't it?
Mhm.
So really, don't we just have x squared plus 90 squared equals z squared?
Which gives you 2
That'll make things a lot easier. So now do the derivative of that code. The hard part's over. Now it's just derivative, plug in the crap you don't know, and then you'll solve for what you do know. Or I said that wrong.
Wait, we still don't know z.
Find it.
How?
How?
You only know y, you don't know, oh, you do know x.
Mhm.
X is 20, oh,
X is
duh.
20, y is 90. You can figure out z.
What?
At the instant this is happening, when we're taking the picture, don't we know x is 20?
Yes?
And don't we know y is 90?
Yeah, but I don't even know what to plug in.
So when you do the
can't we find z because it's just Pythagorean theorem? Or are you still working on the derivative?
No, the derivative, we got 2x dx dt equals
Yeah.
2z dz dt.
Yes.
What if it's not a solid answer?
But that's why you said y, and I didn't get any y in there. That's why I was confused.
Oh, I see what you mean. Point is, we don't, yeah, what was the point? I don't know. Never mind.
Wait, what's,
Oh, she said we don't know z. Do you know z? Because we gotta plug, we're trying to find this, so we need to know everything else. Do you know
Well, you
z?
can put in Pythagorean theorem,
plug in.
regular.
Yeah.
20 squared
Yeah,
plus.
okay.
That's what you. Okay.
what, 164.92 is 164.92. You don't have to write it.
That's a very
You don't
nice
have
observation, Shreya.
You don't have to round it. I do terrible with rounding.
It's a school-wide problem.
I wonder who the teacher is.
Feel your pain.
Holy.
I did not get the same answer.
Did you get z is 92.2?
Point two? Yeah.
So then just plug that in, plug your x in, plug your, yeah, plug stuff in. Done. Shouldn't be.
No, I was looking to check my answer. But it's because
Oh, I assumed getting closer meant the distance was getting smaller, so we didn't know. As long as you know how to interpret your answer, it doesn't matter if you use positives or negatives. Yeah, you can write more positive. Done? Get the answer right?
The answer on your thing's different from mine, though.
Is it just negative? Is the same thing?
You got negative 1/4?
Hello?
No, I got. Well, he got the positive.
6.51?
Yeah, but your paper says negative 1/4. Oh, wait. We're on 8.
I think no, it doesn't.
This came out
I
positive
was like,
because,
what the-
remember at the beginning when I asked you, 30 feet per second that way, is it positive or negative?
But in time, isn't it positive no matter what if you get negative or positive?
No, you just need to, at the very beginning when you draw your picture, if you're saying positive is this way, then this dot's moving this way, your answer is gonna be positive. If you say this way is negative, then your answer is gonna be negative. You just need to know he's getting closer to home plate at a rate of 6.51 feet per second.
Yeah, I got
That's what I'm saying, if you get a positive or negative answer, the rate's the same, right, because it's speed?
Yeah, it'll all depend on how you defined it in the beginning.
Define it.
Because on some of these, like the next one, the rocket one, you can define up as positive, or sometimes you're dropping a rock off a cliff. Sometimes people define the distance. They say, oh, y is the distance from your hand, in which case they make down positive. Or you can say, oh, y is the distance the rock has fallen. Like, you could change it, and as long as you know what you did and label your picture correctly and know how to interpret your answer with the positive and the negative, it doesn't matter. Let me see if I can pick two easy ones up here. Probably the first two.
So homework?
Try the first two. Rocket, yeah, the rocket and boat. Those are easy. Draw a picture. Try the first two.
You want me to stop this?
Yes.
Where'd it go? There's the two you're supposed to try. Pause it. I'm gonna stop it. Oh, it's shaky.